Okay, imagine, just for a moment, this colossal aircraft carrier. I mean, longer than any ship ever built. A floating runway for heavy bombers right out in the middle of the vast, dangerous Atlantic.
Okay.
Now, picture this thing made almost entirely of ice.
Well, not just ice, a special kind of ice.
Right, right. A revolutionary material that could apparently shrug off bullets. It sounds completely wild, doesn't it?
It really does. But this wasn't science fiction. This was a genuine, audacious plan conceived during the absolute darkest days of World War II.
Exactly. And that's what we're diving into today, Project Habbakuk. This incredibly ambitious, frankly bizarre, and, spoiler alert, ultimately scrapped Allied plan.
The idea was to build these giant carriers out of something called Pykrete, and the main goal, to combat the devastating German U-boat threat right in the mid-Atlantic gap.
So our mission today is to really unpack this frozen behemoth concept. We're going to dig into the surprising science that made it even seem possible for a while.
And the monumental engineering challenges, the, logistical nightmares that eventually grounded it.
We'll uncover its strange legacy, too. Expect some, well, truly mind-bending facts.
Yeah.
This is definitely one of World War II's most imaginative secret projects.
Yeah, get ready. We're talking Pykrete, secret labs hidden under London meat markets.
Seriously.
Oh, yeah. A prototype built in a Canadian lake by conscientious objectors who had no idea what they were building.
Wow.
And yes, the almost unbelievable story of a bullet bouncing off ice and grazing an admiral.
Okay, let's set the scene properly. It's 1942. World War II is raging. German U-boats are just running rampant, sinking Allied convoys in the mid-Atlantic.
This was the infamous air gap, basically a huge stretch of ocean beyond the range of land-based Allied aircraft, a perfect hunting ground for U-boats.
Just how bad was it? And why couldn't they just, build more conventional ships or planes?
Oh, it was dire. I mean, thousands upon thousands of tons of vital supplies, food, weapons, all going to the bottom of the ocean. Britain's survival was genuinely threatened.
And the conventional options.
They were bottlenecked. Steel, aluminum, the stuff you build ships and planes out of was in critically short supply, absolutely vital for tanks, guns, existing aircraft production. You couldn't just magic up a new fleet of carriers overnight.
Right. Enter Jeffrey Pike.
Exactly. Jeffrey Pike. He was working for Combined Operations Headquarters, the folks behind the commando raids and special ops. Lord Louis Mountbatten, the head of Combined Ops, actually called him a genius.
I praise.
And Pike had been wrestling with this convoy protection problem. His solution: utterly radical, floating airfields made of ice.
Ice. Because it was cheap. Available.
Cheap to make, theoretically limitless supply, especially in the North Atlantic. That was the core idea.
And he wasn't messing around. He sent this proposal, I read, from New York to Mountbatten in a diplomatic bag.
Yes, with explicit instructions: do not open. Only for Mountbatten's eyes initially.
And Mountbatten passed it up the chain.
Straight to Churchill. And Churchill apparently was quite taken with the idea. You know Churchill, always keen on a bold, unconventional stroke.
Definitely sounds like him. But was Pike really the first person to think of an ice island?
It's interesting, actually. He wasn't entirely the first. There was a German scientist, A. Gurk, who'd proposed something similar and even did some small experiments back in 1930.
1930?
Yeah, on Lake Zurich. And even the British Admiralty had apparently joked about ice islands in 1940. So the basic concept, using ice structurally like that, was sort of floating around, you could say.
Okay, fair enough. But turning a joke into a serious military proposal, especially one involving ice ships, there must have been some kind of scientific breakthrough, right? What was the secret sauce?
Absolutely. The real game changer, the thing that made Habbakuk seem plausible, was the development of Pykrete. And this came from Max Perutz and his team.
Perutz, the Nobel Prize winner.
The very same. Although this was wartime work, obviously before his famous work on hemoglobin, his group developed Pykrete. It's basically a composite material.
So not just frozen water. What's in it?
A mixture of water and wood pulp. About 14% wood pulp, 86% water, turned out to be optimal.
Wood pulp, like paper pulp.
Essentially, yes.
Mm.
And when you freeze this mixture, the results are, well, astonishing.
How so? What made it better than regular ice?
Okay, several things. First, it was way stronger than plain ice, much more resistant to shattering or impact.
Mm.
Second, it melted much, much slower. The wood pulp acted as an insulator and binder.
Okay, stronger, melts slower. Anything else?
Yeah, crucially, it wouldn't just sink if damaged, unlike a steel ship with compartments breached. And get this, it could apparently be machined like wood or cast into shapes almost like metal.
You could shape it.
Yes, and when it was in the water, the outer layer of wet wood pulp formed this kind of protective, insulating skin, shielding the ice inside from melting further. Pretty clever.
And the name, Pykrete, after Pike.
Named after Pike, yes. Though there's a possibly embellished story about him being inspired by Inuit reinforcing sled runners with moss and freezing them. Who knows if that part's true?
So they've got this wonder material, Pykrete. Seems like the answer to their prayers, right? Solves the U-boat problem, uses cheap materials. But I sense a but coming.
Oh, there's always a but in these grand wartime projects, isn't there? The engineering reality started to bite pretty quickly.
What was the big hurdle?
Max Perutz himself discovered a major issue during his experiments. It's called plastic flow, or creep.
Plastic flow. What's that?
Basically, ice, even Pykrete, isn't perfectly rigid over time, especially under immense pressure. Think glaciers, how they slowly flow.
Okay.
On the massive scale of a 2 million-ton ship, this meant the whole structure would slowly sag, deform, and basically lose its shape under its own weight. Unless it was kept incredibly cold. We're talking minus 16 degrees Celsius. That's about 3 degrees Fahrenheit.
Minus 16 C constantly for the entire ship.
The entire ship, which meant you needed massive amounts of insulation. You needed a huge, powerful refrigeration plant built into the ice ship, and a complex network of ducts running throughout the hull to circulate the freezing air. Suddenly, it wasn't looking quite so simple or cheap.
And where was Perutz figuring all this out? You mentioned something about a meat market.
Oh, this is one of the best details. Get this. His lab space was a refrigerated meat locker underneath Smithfield Meat Market in London.
You're kidding.
Nope. Hidden behind a literal screen of frozen animal carcasses. Talk about top secret and slightly macabre. Doing cutting-edge materials science next to sides of beef.
That is absolutely bizarre.
Oh, yeah.
A meat locker lab. Okay, so the theory's developing, challenges emerging. What's next? Do they try building one?
Not a full-size one, no. That would have been insane at that stage. But they decided to build a large-scale model, a proof of concept.
Where did they do that? Not London, I assume.
No, they needed somewhere cold and remote. They chose Patricia Lake up in Jasper National Park, Canada.
Okay, Canada makes sense. How big was this model?
Pretty substantial. 60 feet long by 30 feet wide, weighing about 1,000 tons.
1,000 tons of Pykrete. And how did they keep that frozen, given the cold flow problem?
Here's another surprising thing. It was kept frozen by a relatively small, just 1 horsepower motor powering the refrigeration.
Only 1 horsepower for 1,000 tons.
It shows how effective Pykrete's insulation could be, at least on that scale, once you got it properly cold.
And who built this thing in the middle of nowhere?
This is another strange twist. The workforce was mainly made up of conscientious objectors.
Conscientious objectors. Building a secret weapon prototype.
Well, they weren't told what it was. They were assigned to alternative service, like forestry work, in the area. They were just told to build this large ice structure for a secret wartime purpose. No idea it was a ship model.
That's incredible. So what did they learn from this Canadian prototype?
Its main purpose was to test insulation methods, the refrigeration system design, and critically, how Pykrete held up against actual artillery fire and explosives. They needed to know if it really was tough.
Right. But even with the prototype, the costs and complications must have been mounting for the full-scale version.
Dramatically. The initial rough estimate for a full Habbakuk carrier was maybe 700,000 pounds.
Which is already a lot back then.
A huge amount. But Perutz's findings on cold flow, the need for that intense refrigeration, the steel reinforcement required inside the Pykrete, it all added up.
How much did the estimate jump?
It ballooned to around $2.5 million per ship. A staggering figure.
Ouch.
And the Canadians doing the prototype work, they were already saying it looked impractical to build a full one in time for the coming season. The timelines were slipping.
It really shows that tension, doesn't it?
The
brilliant, maybe crazy idea and the harsh realities of wartime resources and logistics.
Absolutely. And speaking of complications, there was also some political maneuvering happening.
Oh.
Jeffrey Pike, the originator of the idea, he actually got sidelined from the project.
Genius got cut out. Why?
It seems it was partly an effort to get the Americans more involved and invested. Pike had apparently clashed with U.S. personnel on a previous joint project, Project Plow, something about snow vehicles.
So, potentially seen as difficult to work with.
Potentially. Bernal, another key scientist involved, seemed to support his exclusion to smooth things over with the Americans. So the original visionary was pushed out.
That seems counterintuitive. losing the driving force behind it.
It happens, but the work continued through the summer of 1943. Naval architects, engineers, Bernal, Perutz, they kept refining the design, but the requirements just kept growing.
Bigger and better, or just more complicated.
Both, really. The
Yeah.
demands became incredibly ambitious. Range needed, 7,000 miles, had to withstand the biggest waves ever recorded.
Okay.
The Admiralty insisted it be torpedo-proof. That meant a hull thickness of at least 40 feet.
40 feet of Pykrete.
40 feet of Pykrete, yes. And then the Fleet Aeron decided they wanted heavy bombers to operate from it, not just fighters.
Heavy bombers. That needs a huge runway.
Exactly. The flight deck requirement jumped to 2,000 feet long.
Just mind-boggling scale. Were there any problems they just couldn't solve?
One massive one was the rudder. How do you steer a 2.2 million ton ice behemoth? They calculated they'd need a rudder over 100 feet high.
100-foot rudder.
Yeah. And how to actually build, mount, and control something like that effectively. They never really cracked it.
Wow. Did they finalize any specific designs amidst all this?
They came up with 3 main variants based on Pike's concept. Habbakuk was an all-wood design, quickly dropped. Too vulnerable, impractical.
Okay.
Habbakuk II was the main event. The monster Pykrete version. 2,000 feet long, 300 feet wide, displacing 2.2 million tons.
That's just immense. How would it even move?
Power was another headache. They estimated needing 33,000 horsepower from 26 electric motors. But here's the catch. The motors had to be in external nacelles, pods outside the main hull.
Why external?
Because conventional internal engines would generate far too much heat. You can't have massive engines warming up your giant ice ship from the inside.
Right, of course.
Yeah.
The heat. What about weapons and aircraft?
Habbakuk II was designed to carry up to 150 twin-engined aircraft bombers, or fighters, and for defense, 40 twin-barreled 4.5-inch dual-purpose gun turrets, plus lots of smaller anti-aircraft guns. A floating fortress.
And Habbakuk III.
That was basically a smaller, potentially faster version of Habbakuk II, maybe slightly more achievable, but still enormous.
Okay, enough blueprints. Let's get to that story you mentioned, the infamous shooting incident. This really highlights the Pykrete itself, doesn't it?
It absolutely does. It's one of those historical anecdotes that sounds too good to be true, but apparently something very much like it happened. There are slightly different versions.
Give us the most dramatic one.
Okay, one popular version puts it at the Quebec Conference in August 1943. High-level meeting Churchill, Roosevelt, top military brass are all there.
Right.
Lord Mountbatten wants to demonstrate Pykrete's amazing properties. So he brings in 2 blocks of ice. One is regular ice, the other is Pykrete.
Okay, visual aids, I like it.
He pulls out his service pistol. First, he shoots the regular ice block. Bang! It shatters, fragments fly everywhere. Very dramatic.
Standard ice behavior.
Exactly. Then, he aims at the block of Pykrete, ready to show how tough it is. Fires again. And the bullet ricochets off the Pykrete block. It supposedly zinged across the room, grazed the trouser leg of U.S. Admiral Ernest King.
No, grazed the Admiral.
Grazed the Admiral's trousers and then thumped into the wall. Can you imagine the silence in that room?
That's incredible. Is that confirmed?
Well, Sir Alan Brooke, chief of the Imperial General Staff, mentioned a similar incident in his diary where a bullet fired at Pykrete buzzed round our legs like an angry bee. Max Perutz himself described a demo at Combined Ops HQ where a bullet ricocheted and actually hit Sir Alan Brooke in the shoulder.
Hit him. Was he okay?
Apparently it wasn't serious, more of a shock. But whichever version is precise, the point was forcefully made. Pykrete was astonishingly tough and definitely bulletproof, maybe a little too good at deflecting bullets in closed rooms.
What a story. Okay, so Pykrete is tough. The prototype works after a fashion. Mountbatten and Churchill are keen. Yet, Habbakuk never fails. Why? What finally killed the frozen dream?
By late 1943, the initial enthusiasm was colliding hard with reality. That prototype on Patricia Lake, while successful in some ways, really drove home the scale of the challenges.
The cost.
The cost, yes, but also the sheer resources. Building one full-size Habbakuk was projected to cost more in money and machinery than building an entire fleet of conventional escort carriers.
More than a whole fleet.
Yes. And think about the steel. Just the steel needed for the internal refrigeration plant and ducting system was more steel than it took to build a conventional steel aircraft carrier from scratch.
That completely defeats the original purpose of saving steel, doesn't it?
Utterly. It turned the core logic on its head. It wasn't just the Pykrete anymore. It was everything needed to maintain the Pykrete.
And the war itself wasn't waiting for them to figure this out.
Exactly. The strategic situation in the Atlantic was changing rapidly through 1943. Mountbatten himself listed the key reasons later. 1. Steel was desperately needed elsewhere for landing craft, for D-Day, other ships, etc. 2. Portugal finally granted the Allies permission to use air bases in the Azores.
Ah, the Azores.
Yeah.
That's right in the middle of the Atlantic Gap, isn't it?
Precisely. Suddenly, land-based patrol bombers could cover the gap. Habbakuk's primary mission was becoming redundant.
Any other factors?
Yes, Allied aircraft were being fitted with longer-range fuel tanks, extending their reach anyway, and crucially, the number of smaller, cheaper, quicker-to-build conventional escort carriers was increasing significantly. They were proving very effective.
So multiple factors just converging against Habbakuk.
Right. The need lessened, the cost and complexity became undeniable, and better, more practical solutions emerged.
When did they officially pull the plug?
The final nail was probably a meeting in December 1943. The official conclusion was blunt. The large Habbakuk II made of Pykrete has been found to be impractical because of the enormous production resources required and technical difficulties involved.
Game over.
Pretty much. Mountbatten also formally withdrew his support around then. The tide had fully turned. Even before that, other floating island ideas were being looked at, like welding Liberty ships together, Project Tentacle. The ice ship idea just faded.
And that prototype in Canada,
Yeah.
1,000-ton block.
It just sat there and melted, but incredibly slowly. It apparently took 3 hot Canadian summers for it to melt away completely.
3 summers. That says something about Pykrete's persistence.
It really does. The internal wooden structure and the refrigeration machinery eventually sank to the bottom of Patricia Lake, and parts of it are apparently still there. A historical marker tells the story now.
Were people critical of the project afterwards, looking back?
Oh, definitely. Sir Charles Goodeve, who was high up in naval research, was quite scathing. He pointed out the sheer resource drain. The wood pulp needed would have crippled paper production.
I hadn't thought of that.
Each ship needed maybe 40,000 tons of cork for insulation, thousands of miles of steel tubing for the cooling ducts, 4 dedicated power stations worth of energy just for the refrigeration.
Just unsustainable.
And even if you built it, he argued, its top speed was projected to be only about 6 knots. A massive slow-moving target, a sitting duck, really.
6 knots. Barely moving. So strategically questionable, even if they could build it.
That was his argument. It became a case study in, well, perhaps ambition outstripping practicality.
Yet the idea itself, this bizarre ice ship, it hasn't really died, has it? It pops up in popular culture. People have tried to recreate Pykrete.
It has this legendary status. The U.S. show Mythbusters tackled it in 2009.
What did they do?
They built a small boat, called it Yesterday's News, using Pykrete made from newspaper pulp instead of wood pulp.
Newspaper Pykrete. Did it work?
Sort of. They actually got it moving quite fast in Alaska, maybe 25 miles per hour, but it started leaking pretty badly after only 20 minutes.
So not quite ready for the North Atlantic.
Not quite. Their verdict was plausible but ludicrous. They did confirm Pykrete was stronger, melted slower, and was bulletproof compared to regular ice.
Anyone else try?
Yeah, the BBC show Bang Goes the Theory tried in 2010. They used hemp fiber mixed with water.
Hemp Pykrete. How did that go?
Not well. It apparently started leaking almost immediately when they launched it. They had issues with the structure where they mounted an outboard motor.
So modern attempts confirm the basic properties, but also the massive difficulty in scaling it up and making it structurally sound, especially for something like a boat.
Exactly. The material science is fascinating, but the engineering and logistical challenges of building something truly massive and functional out of it, they remain immense, maybe even impossible with current tech, let alone 1940s tech.
So wrapping this up, Project Habbakuk. Truly visionary, incredibly ambitious, pushed the boundaries. But ultimately, yeah, impractical on a staggering scale.
Impractical, definitely. But, it wasn't entirely a waste. It forced engineers and scientists to think way outside the box about materials and large-scale construction under extreme pressure.
What are the big lessons, do you think?
Well, it's a pretty stark lesson in understanding the difference between lab potential and real-world application at scale. It highlights the dangers of escalating requirements, scope creep on mega projects, and, crucially, the need to constantly reassess feasibility against changing strategic needs and available resources. Don't fall for the sunk cost fallacy.
Good points. It's easy to get swept up in the sheer audacity of it all.
It really is. But sometimes the most valuable lessons come from the projects that don't succeed, right?
That leads to a final thought, maybe. What does it really say about us, about human ingenuity and perhaps desperation, that during wartime, such a colossal, almost fantastical frozen dream came so close to being attempted.
And maybe think about this too. How often do these seemingly outlandish ideas, even the ones that fail spectacularly like Habakkuk, end up sparking completely unrelated discoveries or influencing future thinking in ways nobody expected at the time? Even failures can have unexpected ripple effects.
Something to definitely ponder.